Atmospheric pressure is the weight of a column of air contained in a unit area. It decreases with height. Rate of decrease is roughly 1 millibar/10 meters. Wind is the horizontal movement of air that flows from high pressure to low pressure areas. Air current is the vertical or nearly vertical movement of air. Distribution of air pressure. It is not uniform and varies both vertically and horizontally on the Earth's surface. Lower layers have a higher density and exert more pressure. Vertical variation. Z decreases with an increase in altitude in the lower atmosphere, but not at the same rate due to variations in air density controlling factors such as temperature, water vapor, and gravity. Z. The vertical pressure gradient force is much larger than that of the horizontal pressure gradient. Pressure gradient is the ratio between the pressure difference and the actual horizontal distance between 2 points. Z. A rising pressure indicates stable weather, whereas a falling pressure indicates cloudy and unstable weather. Horizontal variation. Z. Studied by drawing isobars, line connecting points that have equal values of pressure. Z. Close spacing of isobars expresses a steep pressure gradient. Factors responsible for variation. Z. High temperatures lead to rise of air, hence low pressure, and vice versa. Z. The Earth's rotation leads to rise of air at equator and fall in tropics, hence, equator has low pressure while tropics have high pressure. Z. Air with a higher quantity of water vapor has lower pressure. Forces affecting the velocity and direction of wind. Z. Pressure gradient force from high pressure to low pressure. Closely spaced isobars indicate strong pressure gradients and hence stronger winds. Z. Frictional force affects the speed of the wind due to Earth's surface irregularities, greatest at the surface and minimal over the sea surface, and generally extends up to an elevation of 1 to 3 kilometers. Z. Coriolis force. The rotation of the Earth about its axis produces a pseudo-force affecting the direction of the wind, deflects the wind to the right direction in the northern hemisphere and to the left in the southern hemisphere, by ballot law, which depends on the wind velocity. It is directly proportional to the angle of latitude, maximum at the poles, and is absent at the equator. Thus cyclones are not formed at the equator. Acts perpendicular to the pressure gradient force, creating cyclonic conditions. Higher the pressure gradient force, higher the velocity of the wind, and the larger is the deflection of the wind. General circulation of the atmosphere. Pattern of movement of the planetary winds also sets in motion the ocean water circulation, and they together influence the Earth's climate. The pattern of planetary winds largely depends on Z. Latitudinal variation of atmospheric heating. Z. Emergence of pressure belts. Z. The migration of belts follows the apparent path of the sun. Z. The distribution of continents and oceans. Z. The rotation of the Earth. Global pressure belts. The horizontal distribution of air pressure across the latitudes is characterized by high or low pressure belts. 8. Atmospheric circulation and weather systems. 32. Atmospheric circulation and weather systems. Equatorial low pressure belt. Zone of wind convergence along the equator and within 5 degrees north and south. This belt has doldrums. Doldrums, zone of calm air, due to virtual absence of surface winds at 0 degrees latitude. Z. Thermally induced pressure belt, as it is formed because of the differential heating of the Earth. Z. Due to the overhead sun throughout the year, the air gets warm and rises over the equatorial region, producing equatorial low pressure. Z. Only conventional currents are present. Horizontal movement of air is absent due to excessive heating. Z. Zone of convergence of trade winds from 2 hemispheres from subtropical high pressure belts. Z. Vertical winds, convection, carry moisture to cumulonimbus clouds and lead to thunderstorms, convectional rainfall. Z. It is also known as intertropical convergence zone, IDCZ, or thermal equator because the winds flowing from subtropical high pressure belts converge here. Intertropical convergence zone, IDCZ, low pressure forms due to air convection driven by intense sunlight. Winds from the tropics converge into this low pressure area, ascend within the convective cell, reach the troposphere's upper limit, approximately 14 kilometers, and subsequently travel poleward, accumulating around 30 degrees north and 30 degrees south latitudes. The position of the belt varies with the apparent movement of the sun. Zero Coriolis force, so no cyclones at the equator. Subtropical high-pressure belt. Zone of wind divergence along 30 degrees north and 30 degrees south latitude. Dynamically induced pressure belt as it is formed because of the rotation of the Earth. Uprising air of the equatorial region moves towards the poles and gets deflected due to the Earth's rotation. After becoming cold and heavy, it descends at these high-pressure belts. The corresponding latitudes of subtropical high pressure are called horse latitudes due to calm weather conditions and absence of strong winds. Subsiding air is warm and dry. Therefore, most of the deserts are present along this belt in both hemispheres. Cold ocean current increases the aridity of these deserts on the western margin of continents. Winds blow out of this region towards the equator. Northeast trade winds, northern hemisphere, and southeast trade winds, southern hemisphere. These winds bring rainfall to the east and aridity deserts to the west coast of continents within the tropics. Winds blow out of this region towards the temperate low-pressure belt. Southwesterlies, northern hemisphere, and northwesterlies, southern hemisphere. These carry warm equatorial waters into western coasts of temperate lands. UPSC 2015. In the southern hemisphere, westerlies are referred to as roaring 40s, furious 50s, and shrieking or stormy 60s according to their speed at different latitudes. Subpolar low-pressure belts. Zone of wind convergence towards the pole along 60 degrees north and 60 degrees south latitudes. Dynamically induced pressure belt as it is formed because of the rotation of the Earth. Winds coming from the subtropical and the polar high belts converge here to produce cyclonic storms or low-pressure conditions. This zone of convergence is also known as the polar front. Polar high-pressure belt. Close to the poles between 80 to 90 degrees N and S latitudes. Thermally induced pressure belt as it is formed because of the differential heating of the Earth. In polar regions, sun rays are always slanting, resulting in low temperatures. Because of low temperature, air compresses and its density increases. Hence, high pressure is found here. Winds from these belts blow towards the subpolar low pressure belt. Atmospheric circulation and weather systems 33. Pressure cells. The wind belts girdling the planet are organized into 3 cells in each hemisphere. Hadley cell. Warm air at the IECZ rises, creating a low pressure zone, and winds from the tropics blow towards this equatorial low-pressure zone. The converged air rises and moves towards the poles. This causes accumulation of air at about 30 degrees north and S. This air gets cooled and sinks to ground and forms a subtropical high. Again, this sinked air flows towards equatorial low from the subtropical high as easterlies. Ferrel cell. Circulation of air with sinking air at subtropical high and rising air at subpolar low forms ferrel cell. These winds blowing at the surface are called westerlies. A large part of the energy that drives the ferrel cell is provided by the polar cell and Hadley cell circulating on both sides, which drag the ferrel cell with it. Polar cell. At polar latitudes, the cold dense air subsides near the poles and blows towards middle latitudes, subpolar low, as the polar easterlies. Near 60 degrees latitude, air rises to the tropopause and moves poleward. As it does so, the upper level air mass deviates toward the east. When the air reaches the polar areas, it has cooled and is considerably denser than the underlying air. It descends, creating a cold, dry, high-pressure area. At the polar surface level, the mass of air is driven towards 60 degrees latitude, replacing the air that rose there, and the polar circulation cell is complete. The air flows at the surface are called the polar easterlies. Polar cell, Hadley cell, ferrel cell. North pole, polar high, 60 degrees north, subpolar low, 0 degrees north, IDCZ low, 30 degrees north, subtropical high. Mirror image in southern hemisphere. Geostrophic winds. They are the winds of upper atmosphere, 2 to 3 kilometers above the surface, that are free from frictional effect of the surface and are controlled mainly by the pressure gradient and the Coriolis force. They flow parallel to the isobars because of the balancing of the pressure gradient force by the Coriolis force in the upper troposphere. These winds can also form in a cyclonic or anticyclonic circulation. It is also the reason why the air rising from the equatorial belt does not go straight towards the pole but descends in the subtropics. Gradient wind considers airflow along a curved path, extending the concept of geostrophic wind moving along straight and parallel isobars. One important type of geostrophic wind is the jet stream. Jet streams. Jet streams are fast, narrow and meandering winds in the upper atmosphere circumnavigating the globe in reach speeds of 400 to 500 km per hour. These winds blow from west to east in both hemispheres, westerlies. Seasonally shifting with the sun. In summer its position shifts towards the poles and in winter towards the equator. Disturbances in jet streams affect weather, precipitation patterns, and agriculture. Formation and characteristics. Jet streams form due to temperature disparities, with greater differences intensifying wind speed. Coriolis force and low friction at high altitudes contribute to their formation. Jet streams undergo a geostrophic flow and form atmospheric cells. Types. Permanent jet streams. Polar jet stream, mid-latitude flows between polar and feral cells, consistent year-round flow in mid and higher latitudes. Strength and intensity vary with seasons. Subtropical jet stream, STJ flows between Hadley and feral cells, continuous in the southern hemisphere, intermittent in the northern hemisphere during summer, nearly continuous in both hemispheres during winter, influences Indian monsoons. 34 Atmospheric circulation and weather systems. Polar front jet stream, PFJ flows between feral and polar cells, more variable position than the subtropical jet stream, stronger and more regular in winters. Temporary jet streams tropical. Tropical easterly jet stream, TJ dominant in the northern hemisphere in summer, found between 5 degrees to 20 degrees north, influences South Asian monsoon. Somali jet stream, occurs during the summer over northern Madagascar and off the coast of Somalia, intensifies from June to August, impacts. South Asian monsoon, major cross-equatorial flow from the southern Indian Ocean to the central Arabian Sea. Significance. Jet streams influence air mass movement, weather dynamics, and storm tracks. The polar front jet strength determines mid-latitude weather, impacting precipitation and cyclones. Jet streams play a vital role in the onset and progression of monsoons and influence the general circulation patterns in tropical, temperate, and polar regions. Classification of winds. Permanent winds, periodic winds, mesoscale, local winds. Hot winds, cold winds. Trade winds, westerlies, polar easterlies. Monsoon, land and sea breezes, mountain and valley winds. Lu, Fein, Chinook, Zonda. Bora, Pampero, Gregale, Tramontane, Mistral. Planetary winds. The pattern of the movement of the planetary winds is called the general circulation of the atmosphere. It also sets in motion the ocean water circulation, which influences the Earth's climate, flow in the same direction throughout the year. There are 3 types of planetary wind. 1. Trade winds or easterlies, blow from subtropical, high-pressure belt towards equatorial low-pressure belt. Because of the Coriolis effect, trade winds in the northern hemisphere move away from the subtropical high towards the equatorial low in northeast direction, northeast trade winds. In the southern hemisphere, they diverge out of the subtropical high towards the equatorial low in southeast direction, southeast trade winds. Blow mainly from the east, so also known as tropical easterlies. 2. Westerlies, blow from subtropical high-pressure belt towards subpolar low-pressure belt. Deflected to the right in the northern hemisphere and thus blow from the southwest. Deflected to the left in the southern hemisphere and blow from the northwest. Westerlies of the southern hemisphere are stronger, known as roaring 40s, furious 50s, and screaming 60s, and more consistent in direction due to the predominance of water, lower resistance. 3. Polar easterlies, blow from polar high-pressure belt towards subpolar low-pressure belt. In northern hemisphere, from northeast to southwest, and in southern hemisphere, from southeast to northwest.